the
Millions.
millions, and then the 10 millions. Where does the 9 go in this problem?
On the first one.
Yep. And then a bunch of zeros. 90 million.
Mhm.
Any questions on that?
No.
Okay. I'm going to try and do these in order, but if you see one that I've not done that I've missed or something, just let me know, and we'll go back here because I don't know why. Maybe so. The next one I see is like number 7. So we'll go to that one here. It says order from least to greatest. Think of these numbers as being on a number line. Least means to the left, greatest means to the right. All right. And I think it's actually good for you to either start from like whichever one you feel like you're more comfortable with. Like is greatest, do you feel like you can figure out the greatest one or the least one? Which one do you think is more intuitive to you?
Greatest.
Okay, so which in this number set here is the greatest?
8.
8. So you put an 8 all the way to the right and then cross it out. Very important to do that. Then what's the next greatest?
5.
5, cross it out. Then what's the next greatest?
0.
You got it. Now we're into the negative territory. -2, -7, -10. You can go back and do the least if you want. You can keep going with from the greatest. What do you think here?
Let's go least.
Okay, so which is the least?
10.
-10. -10. That negative is really important. Very important. Like it's the difference between like going right versus left. All right, so cross it out. What's the next least or the more to the left?
-7.
-7. And then the last one there is
Negative.
-2. Do you have a number line?
No.
You know what I'm talking about when I say number line though?
No.
Okay, let me snip one in front of you here. Because that's really the key to doing these problems from least to greatest. So this number line, zero is right in the middle. There's 0. This is the least. This is the greatest. That's how you do these problems. Any questions on that?
No.
Okay, now I can always give you a problem like this one. Like, let's just say you're like, Matthew, I really need another one here. I didn't quite get it. That's okay. So the next one here refers to your student reference guide. See the times table in the student reference guide. Do you have a student reference guide somewhere?
No.
Well, we need to get you one. Do you have a multiplication table handy?
No.
Okay. Do you remember what two numbers multiply together to give you 49?
Yeah.
What is that?
7.
Times 7. How about we get to 64?
8.
8 times 8.
Yeah.
How about to get to 81?
9.
Are you seeing a pattern here?
Yeah.
Okay, what's the next one?
10.
10 times 10.
Mm-hmm.
So what is the pattern for the missing one here? What's the missing one? What two numbers multiply together?
20.
Well, wait a second. You just went up 7, 8, 9. What do you multiply to get 100? What two numbers?
10. 10.
10 and 10. So do you see a pattern here? 7 times 7, 8 times 8, 9 times 9.
Mm-hmm.
What's the pattern?
It goes up by 1.
Okay, so what's the next number after 10?
11.
Okay, so what's 11 times 11?
Um.
So it's really good to have some sort of a multiplication table available to you. On my website, I've got a multiplication table. Let me just send you a link to that.
Mm-hmm.
I'll drop that in the chat here in case you want to look at that later. So let me snip in the multiplication table and I'll have it up here for some of our our problem sets here. Just a moment. I didn't know I didn't know we were going to need this up, but let me get that out. Okay. So the way a multiplication table works is the two numbers you're multiplying are on the rows and columns. Okay.
Mhm.
So like when you're multiplying 11 and 11, you go and you find the intersection of the two. So what is 11 times 11?
121.
121. And that's a number you want to remember. You want to remember that. All right. How about the next one here? How about this next position?
12 times 12.
Exactly. Let's go back and look for it. There's 12. There's 12. What's the intersection?
144.
44. Good. And then the last one there is 13 times 13. What does that multiply to?
156.
Close. It's going down the diagonal. What should it be?
169.
169. Good. Excellent. Okay. Any questions on that?
No,
Are you homeschooled?
no.
Okay. You might want to ask your teacher where the student reference guide is, just so you know where it is, because I'm sure a lot of these problems refer to that here. All right, number 13. Number 13 looks to be next. Okay. All right, so 100. They're trying to show you, or you're trying to figure out the math operation here. This one is not very clear. I'm just going to tell you it's subtracting. We'll get to why in a moment, maybe. But do you remember how to subtract a number with borrowing?
Yeah.
Okay. Do you want to give this one a try on your own?
Um, I don't really know.
Okay. So can you take 0 and subtract 4?
Mm-hmm.
You can?
No,
No, you cannot. What's the problem with that? What's the problem with the 0 relative to the 4?
it's smaller than the 4.
Yeah, 0 is smaller, and that's bad. Okay, so we have to borrow, but there's nothing to borrow from, right? You can't borrow from there, you can't borrow from there, you can't borrow from there. Do you remember at all how to do this from class, or is this totally new, foreign to you?
I remember, I just forgot.
Okay, so you go until you borrow. You can borrow from the 1. And so you actually change all of these into 9s. 9, 9, 9, and then the last one is 10. So you
Mm-hmm.
put a little 1 there, and now you can subtract. So 10 minus 4 is what?
6.
6. 9 minus 5 is
4.
9 minus 7 is
2.
okay. 9 minus 1 is
8.
all right. So what is your final answer here?
$82.46.
Yes. Okay. Go ahead and get down some notes here or some get the problem down. I want to give you one to do like this for you to try on your own.
Mm-hmm. What's happening? It's working.
You did you get this down?
Yeah.
Okay, let me know when you've done that because I cannot see your screen, can't see your paper. All right, so here's one for you to try. Let's do 100 again minus 35.68. Okay, so this is very similar to the one you just did, just different numbers. Give this a try. Let me know your answer, or let me know if you have any questions.
There's paper here. Here. Just take, that's why I left this here. This is for you.
You have some paper now in front of you? Aiden?
Yeah.
All right, give this one a try. Let me know if you have any questions.
I got it.
All right, what is your final answer?
$64.32.
Very good. Okay. Let's take a look at 14. So I didn't really address this in the previous problem, but we now can talk about some operations here. Okay, so this says W minus 98 equals 432. Is W bigger or smaller than 432? Like you're going to subtract something from it to get 432. So is the answer bigger or smaller than 432?
Bigger.
Bigger. So bigger means you're going to add, smaller typically means you're going to subtract, you're going to add these numbers together. Now there is carries involved here. Is that something you know how to do, or do you need some help with that?
I need help. Oh no,
Okay,
actually I know how to do it.
you know how to do it? Okay, give that a try. Let me know what you come up with.
I got it.
Okay, what is your final answer?
530.
Yes, 530. Very good. Okay, great. All right, so I believe that is everything from your homework assignment. Does that look right to you, that is everything?
Yeah.
Okay. We've got a practice test we can look at next, or you can say, hey, Matthew, you know what? I really want some more problems like some of the ones we were doing today. Do you want any more problems like this? Do you want us to go to that practice test? What would be best for you?
We still have more on this back page.
Yeah, I don't see the other problems that you need to do. I only see stopping at 14. What's the next problem you see? What problem number?
23.
All right, you'll have to ask mom to send that over to me, please.
Okay, let me go get it. Okay, she's getting it.
Okay, sounds good. I'll stand by for those. Are you playing any sports? Are you doing any clubs or activities?
No.
All right. Well,
Which side?
This side.
Oh, this side, okay. Let's see. I didn't know, I thought you said only 5. Did you do this set?
Yeah.
And how about this?
Yeah.
You didn't write anything down. You can actually rewatch
I have to
it.
do the back.
Okay, I just sent it to Matthew.
got it. Yep, I got it. Thank you so much.
Okay,
Good
sure.
for those.
You're doing good?
Mhm.
Okay, great.
Okay, so give me just a moment here. Wow, why aren't these uploading? All right, try one more time here. There they are. All right, so number 23, you said?
3, yeah. Aiden, tell
All
me
right.
which ones are highlighted.
23.
I got it. Yeah, just making sure. You don't, sometimes I go off and we do problems that we don't need to do. So let's take a look at these. All right, given expression 8 times 7 times 5. Okay, so what you're supposed to notice here, and I'm gonna highlight, well, let me actually use a different color here. You're supposed to compare this to this. And what do you notice? It's the same three numbers, but what do you notice about the numbers between these two circles? Tell me what you see.
What?
What's different about them, or what's the same?
ugh, um, they're all odd.
Well, if 8 is an even number, what I'm talking about the numbers themselves. Like there's an 8, a 7, and a 5, a 7, and an 8, and a 5. There's the same three numbers, but what do you notice about their order?
Um, I don't see anything.
Okay, let me try to help here then. Do you notice that the 5 is in the same position? It's in the third position.
Yeah.
What do you notice about the 8 and the 7?
Uh, they're they're swapped.
They're swapped. Yeah. So the idea is that order doesn't matter in multiplication. When you multiply, the order does not matter. They're switching the order. That is the commutative property of multiplication. So you want to think of the commutative property as order does not matter. Is that okay?
Mm-hmm.
All right. Now, let's take a look at this one. 7 times 8 times 5. And I know it's a little bit hard to see, but actually let's go. I guess they're doing it in order here. This is not very good the way they're doing this. Okay. Let me put another thing up. Let me do this differently. Give me just a moment here to snip this in slightly differently so it's clear. Okay. All right. So let me add one more thing here. All right. What is the difference between what I've written and what is written here? What is the difference that you see?
Um, they're swapped.
They're not swapped again. Swapped would be like 7's in the same position, 8's in the same position, 5's in the same position. What do you see that's different though? There is a big difference here.
The parentheses.
Yes. The parentheses is around 7 and 8. Now the parentheses is around 8 and 5. When the parentheses moves, if the parentheses moves, that's called the associative property. Now, the reason it's multiplication is because you're multiplying.
Mm-hmm.
Okay, now, how do you remember stuff that's important? What do you do to remember things? Do you write them down? Do you make flashcards? Do you make a Quizlet? What do you do?
What did you say?
Huh?
And I'm asking you what you do to remember things because like you have to somehow memorize that commutative property of multiplication is where the order doesn't matter. The associative property of multiplication is where the parentheses are moving around. What are you going to do to remember that?
Um, I can like make a song about it or something.
Okay, songs are good. YouTube, TikTok, wherever you're going, there's probably a song out there to remember that. That's fine. All right, let's take a look at number 26.
Hold on, I just need a different.
Sure, let me know when you're ready. Are you back?
Okay, I'm back.
All right. Let me know when you're settled here. We can start at number 26.
Mhm.
All right. So it says, which angle is an acute angle? Do you remember what the word acute means?
Mm-mm.
So an acute angle is less than 90 degrees. You might wonder, well, what's a 90-degree angle? 90-degree angle goes straight up and down. This is a 90-degree angle. So can you tell me which one is a 90 which one, I'm sorry, which one is acute?
M and C.
So B, so it's actually BMC, the middle letter has to be the vertex. And the vertex is where it kind of V's,
Mm-hmm.
okay? Do you remember what an obtuse angle is?
Yeah,
What is an obtuse angle?
it's an angle longer than 90 degrees.
Greater than 90, exactly. Yes, very good. Okay. Now a straight angle is, uh, well, it's straight. All right. Which three letters are on a line?
A and C.
AMC. You got it. Very good. Any questions on that?
Um, no.
All right. So 20. So these are more definitions. You know, the ones we just did there, you're going to want to remember those somehow. But let's take a look at the next question, 27. It says perpendicular lines make, let me snip this in. Maybe you already know the answer. So they're trying to help by putting the first letter there, R.
Mm-hmm.
Kind of already mentioned it. So perpendicular lines. So these are lines like this. What kind of angle is this?
All right.
It's a right angle. There you go. You got it.
Mm-hmm.
Okay. Number 28. 28 here. All right. So three segments. Three segments. Can you name any segments that you see here?
X.
X is a point. X, Y, and Z are points. A segment connects 2 points. So basically you need to give me two letters.
X and Y.
Okay, so X, Y, and then you have to put a little line above it like that. Are you okay? Do we need a
I
break?
don't know what's going on. He's kind of like choking. What did you do? You want 5 minutes? Can you just give him 5 minutes?
Yeah, we can take 5 minutes. Just let me
I
know
don't
when you
know.
guys are back.
Go grab some water and come back.
He's doing real well.
Oh, great.
Yeah. So
Does
I
he
think,
know like a lot of things?
yeah, he
I'm
actually knows. So let me just show you up here. He knows his adding and subtracting is fine. Uh, thinking it was a little bit of pattern recognition he was struggling with a little bit, but that was good to see. I'd like to see him work on his multiplication tables. You know, there's games you can play for that or just get cards for stuff like
Yeah,
that. But he did this problem without any help, which is great to
okay,
see. Ordering. So there's a lot of good stuff here. What you had
okay,
some
good.
concerns though? I mean, you weren't sure how he was doing in math or
Yeah, that's the concern. You know, so what they give him is different than what like the sixth graders are getting. Does that make sense? So
yeah,
like sixth grade in his school, they're working on seventh grade math. But
okay,
this is, I believe, like a fifth grade math, right? I think it's like around fifth, sixth. They're trying to close the gap for him so he
okay.
can be on the same curriculum as, you know, his class. So when I help him, he seems like he doesn't know. Like he's like, I don't know. What is it? Tell me, you know, and
Yeah,
probably
there's a little bit of that. Like if I showed him, okay, I did one, I worked out a problem, and then I asked him to do one, and he could do it without issue. So it might just be that he wants to see one to make sure. Like that's the confidence thing that they don't have sometimes.
yeah. And that's what he needs. I mean, he needs somebody like you who can walk him through all this and, you know,
Yep.
show him and even give him
Right.
the right terms, you know, use the right terms and
Exactly. Yeah.
vocabulary math. So, okay,
Exactly.
perfect.
Yeah.
Well, I'm
Whenever he's
happy
ready.
it's working for him.
Yes.
So,
Yes. Whenever he's ready, just have him let me know, or you
yeah,
let me know, and we'll get started again.
let me get him. Okay. I don't know what's going on with him. Aiden, you okay now? Okay, Matthew said you're doing real good. So just keep up, okay? Keep up with the pace.
Aiden, are you ready to continue?
Yeah.
Okay. So we were looking at the 3 points, X, Y, and Z are points. Points are just places in space. Where is and we're looking for three segments. Basically, the two letters make up a segment. So you give me X and Y. What are two other letters that we can use?
Um, Y and Z.
Okay, Y and Z. So you've done, don't forget to put that little bar above it. So you've done X to Y, Y to Z. There is a third here.
Um, X, Y, and Z.
It only needs two letters, the two on the outside. What would the two on the outside be in that case?
Mm,
Like you're right, it's X to Y to Z, but what are the two on the outside?
X and Z.
X to Z. So it's like part, and then the whole thing. Questions on that? Thoughts on that?
No.
Okay, so is that everything from your homework assignment?
Mm-hmm.
All right, so we can go to your
Oh,
review next.
actually, no. We just have. Oh, yeah, that's everything.
Okay, so you've got a cumulative test 2A. Do you see that?
Yeah.
All right, can you get that out in front of you? I'm gonna grab the get the pages up. All right, so let me download that. Oh, I already had that one downloaded. Okay, that's good. All right, let me know when you've got that out. We're gonna start with number one.
Hello.
Yep. Are you ready for us to look up?
Uh-huh.
Okay, so can you read this problem for me, please?
3 dimes is what fraction of a dollar? What percent?
Okay, perfect. Now, a dollar is a dollar. Do you know how much a dime is
Yeah,
in cents? How many cents is it?
10.
10 cents. There are 100 cents in a dollar. So the fraction is 10 over 100.
Mm-hmm.
Okay. Now, do you remember how to reduce that?
No.
Okay. To reduce that, you have to divide the top and bottom number by the same number. So what number goes into both the top and the bottom?
Um, 30.
It's got to go into 10 and 100. 10 and 100.
Um, 10.
Okay. That you can divide both of these by 10. What is 10 divided by 10?
Uh, 0.
Nope. 10 divided by 10 is not 0.
Uh, 2.
Okay. So gotta work on your multiplication and division tables. 10 divided by 10 is 1. They're the same number. If you have the same number, like what do you think 5 divided by 5 is?
1.
1. Good. Now, 100 divided by 10, 100 divided by 10, what that really is, it's asking you 10 times what number gets you back to 100? 10 times what number gets you back to 100?
Um,
And this is where it's like you got to have your multiplication table down.
um,
So like let's just say it was like 5 times what number is 20? Are you okay?
yeah. It's just
Okay,
my throat is really scratchy.
understood. All right. So this is 5 times 4 gets you to 20. 10 times 10 gets you to 20.
Should I just write down what you're writing?
Sure, sure, that's fine. Yeah.
I got it.
Okay. All right. Now, do you know how to convert you gotta go from a fraction to a percentage? Fraction to a percentage. Do you know how to do that? Go from one to the other?
Yeah.
You do. Okay. Let me give you a fraction. 45 out of 100. What is that as a percentage?
Um, 45%.
Yes. Very good. Now, what if it's 10 out of 100? What is that as a percentage?
10%.
10%. There you go. So you've got that down here. B is 10%. You got it?
Yeah.
Okay, let's take a look at the next question here. Get that pulled up. All right, question number 2. All right, so this is another triangle. We'll put some angle stuff earlier. So in this triangle, which segment is perpendicular to AC? So AC is the one going down this way. Perpendicular means that it meets at a right angle.
Um,
So which other segment meets at a right angle?
um, A and B.
A and B though is along the what's called the hypotenuse. Does that meet where the 90-degree angle is?
No.
Nope. All right, so give that one more try.
C and B.
You seem uncertain, but yes, that is the correct answer. See how these meet down here at the bottom?
Mm-hmm.
That is perpendicular. All right, let's take a look at number 3. Oh boy, this one could be a little bit unclear. It says how many 3/4 are in 1? How many 3/4 are in 1? Any idea how to do that?
No.
Okay, let's try a simpler problem. Let's say I asked you how many 1/2s are in 1. What would you say?
Mm, sorry, my throat is running again.
It's okay.
Can I go
How many
like
1/2?
can I go like take something to help it?
Sure, we're getting closer to the end of our lesson, so if you don't think you can continue, let me know.